بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله الأمين. السلام عليكم ورحمة الله تعالى وبركاته. So in the previous videos of the amplitude modulation, we understood what is AM and how the AM signal can be generated using two methods. One is the square law modulator, and the second one is the switching modulator. In this lecture, which will be in two parts, in the first part, we will introduce and explain the principle of demodulation of AM wave. And in the second part, we will explain the working operation of envelope detector, as well as we will try to show you some simulation using the National Instrument software for envelope detector. So in this video, let us see one of the most widely used demodulation techniques for the AM signal. But before that, let us define what do we mean by demodulation. Demodulation is defined as the process of recovering the message signal from the received modulated signal. This is known as demodulation. This process of detection is exactly opposite to that of modulation. So modulation occurs at the transmitter end, and demodulation occurs at the receiving end. As shown in this block diagram, the process of demodulation or detection. Here we have the modulated signal that has been transmitted from the transmitter through the channel and delivered to the demodulator or the detector device, where the demodulator or the detector will extract the message signal or the demodulated signal from the modulated signal. So we extract the information or the message signal from the modulated signal that has been transmitted through the channel. And as we said, this is the process of modulation or detection. So there are two types of AM detector or demodulator, such as envelope detector, and the second one is the square law demodulator. So this envelope detector is a non-coherent type demodulation technique for the AM signal. Non-coherent means for the demodulation of the AM signal, the carrier signal is not required at the receiver end. So in this video lecture, we will understand the working of this envelope detector, and later part of the video I will explain the working operation and show you some simulation of the envelope detector. Square law demodulator has been left as an assignment for the students, and this assignment should be delivered to me using this email showing here under. The email is n.e.iltaib, gmail.com. So what's envelope detector? Envelope detector or demodulator is the simple and very efficient device which is suitable for the detection of a narrowband AM signal. A narrow AM wave is the one in which the carrier frequency is much higher than or as compared to the bandwidth of the modulating signal M of T, or the message signal, which has a frequency FM. So the bandwidth of the carrier signal FC is much higher than the bandwidth of the modulating signal or the message signal. That's what we mean by a narrowband AM signal. An envelope demodulator produces an output signal that follows the envelope of the input AM signal exactly. It is used in all the commercial AM radio receiver. But before that, let us quickly revise a couple of points. So this expression shows the generalized expression of the AM signal, where K sub A is the amplitude sensitivity. So here we have the AM wave signal or the modulated signal. So the amplitude modulated signal S of T is given by AC 1 plus K sub A M of T cosine 2 pi FCT. And as we said, K sub A is the amplitude sensitivity. So this is a generalized expression for the AM signal. For simplicity, if we assume that this K sub A is equal to 1 over AC, the reciprocal of the amplitude of the carrier signal, then the expression for the AM signal will get simplified to S of T equal to AC plus M of T cosine omega CT, where AC plus M of T is the envelope and AC is the amplitude of the carrier signal and M of T is the message signal. Now for the envelope detector, the thing is the shape of the envelope. The shape of the envelope is similar to the shape of the message signal. So somehow if we can recover this envelope of the AM signal, then we can recover the message signal. This is the idea behind the envelope detector. But the thing is, this envelope detector works only when this AC plus M of T, or the envelope signal, is greater than 0. Or in other words, when the modulation index of this AM signal is less or equal to unity. And this is the case of under modulation. So this AM wave represents under modulation signal. Now, whenever this modulation index is greater than 1, or in other words, whenever this envelope signal crosses the 0 points, at that time there will be a 180-degree phase reversal at the crossover point. And if we try to recover such AM signal using this envelope detector, then there will be a distortion in the recovered signal, because the message signal is represented by this envelope, which is crossing the 0 level, coming here and getting up here. So for this envelope detector circuit to work properly, the modulation index mu of this AM signal should be less than 1, as we have seen here in this case, or under modulation. So this is the typical circuit of the envelope detector, which consists of a diode, a capacitor, and a resistor. So we have an ideal diode and RC filter, and the AM signal is applied as an input to the circuit. So this envelope detector circuit has some advantages. One of the advantages of this circuit, that is simple, because it consists of very few components, which is considered inexpensive. And the second one, this circuit does not require a synchronization between the transmitter and the receiver. So it is non-coherent detection process. To explain the working principle of envelope detector, we are considering the case of tone modulation. That means here the message signal is a sinusoidal wave of a single frequency. So let us say here the frequency of the message signal is equal to FM, while the frequency of the carrier signal is equal to FC. So considering the case of this tone modulation, let us understand the working principle of this envelope detector, and we will explain this in the second part in the next video. Thank you very much, and see you soon.